Hello everyone. So I thought what we'd do for this week is we'd focus on paper one. Okay, so what we're going to look at first, I'm focusing on the higher tier for this week. There'll be a lot of crossover topics, so all the grade 4, all the grade 5 topics that are on the foundation paper as well. Well, paper one, obviously we've got the checklist, the revision list, and I've picked out the geometry, the shape topics for this week. All right, and then we're going to do some number topics, some algebra topics, and some statistics, etc. But today's video is all about, I'm going to pick the first 4 topics. So a very quick recap on angles in a polygon. We're going to look at the area of a triangle, we're going to look at the area of a sector, and we're going to look at the surface area of a cuboid. Okay? So first of all, looking at the surface area of a cuboid. So what does that mean? Well, a cuboid, that's a 3D rectangle. Okay, and a rectangle has 6 sides. There we go. All right, so we've got 6 sides. So for the total surface area, that means what is the area all the way around the shape? So what is the combined total of all the 6 sides, all the areas of the 6 sides? So what we're going to do, we'll just call it 1, 2, and 3 for now. So if I just do a little... So there's the first one. Okay, I'm just going to change the colour. There's our second side. And then our third side, we'll just do in a cheeky little orange. There we go. Okay, so there's 3 sides there that we can see. Side 1, we've got side 2, and we've got side 3. Okay, so I'm going to find the area of each of those. So the first one, it's got a width of 9, and it's got a height of 3. Okay, there's our height. So it's got a width of 9 and a height of 3. So 9 times 3 is 27. But I'm going to double it. Okay, I'm going to double it because for every front side, there's also a side at the back. Okay, there's one identical to it at the back of the shape. Similarly, for side 2, it's going to be 9 wide and 2 deep. Okay, it's got a width of 2. So 9 times 2 is 18. And I'm going to double it because for every top, there's a bottom. So the bottom one is also going to be 9 times 2. So that'll be 36. And then for the orange side, side number 3, again, for every one side on this side, there's one on the other side as well. So I'm going to double it in a second. So 3 times 2 is 6. I'm going to double it, and that'll give me 12. So if I add that up now, what we'll have is the total surface area of the cuboid, which is what I've been looking for. So it's going to be 90 plus 12, which is 102. The units are centimetres, and it's squared because anything to do with area is always squared. So 102 centimetres squared. Now move on to angles in a polygon again. So we did cover this a few videos ago, but we'll just have a quick reminder. So a polygon has got 12 sides. It's regular, so that means all the angles and all the sides are the same. Okay, all the angles, all the sides are the same. It's got 12 sides. And it says, what is the size of each of the interior angles? Well, there was 2 formulas, well, the same one, but one switched around, didn't it? So 360 divided by the exterior angle will tell us the number of sides. That was one formula we learned. But that can be switched around. So 360 divided by the number of sides that the shape has will tell us the exterior angle. Okay, well, we know it's got 12 sides. So 360 divided by 12. Okay, well, that's 30. So I know the exterior angle is 30 for that shape. All right, and I'm after the interior angle. I'm after the inside. Well, the exterior angle plus the interior will equal 180 degrees every single time. If I just draw like the corner of a shape, so imagine that's the corner of a shape. This is what we call the interior angle, the inside, and the exterior will always continue the line like that and make 180 degrees, like angles on a straight line equal 180 degrees. Okay, this would be your exterior. So if this is 30, 180 take 30, this must be 150. So the size of the interior angle is 150 degrees. So two little formulas to remember, and it's the same one, but we switch them around depending upon what we're trying to find. So there we go. So that's the bit that we need to be looking at. Okay, for the next video, area of a sector. Okay, so a sector is kind of a piece of a circle. It's not a full circle, we've just got a part of it. In this case, we've got 150 degrees of it. So there's no different in the way that we work out the area of a sector as opposed to the area of a circle. It's the same way that we work it out. Okay, so the area of a circle is pi times by the radius squared. Okay, but I've not got a full circle. I've got 150 degrees, okay, out of a full 360. All right, a full circle would be 360 degrees. I've not got a full circle, I've got 150 degrees of it. So the only difference is between area of a circle and area of a sector is I have to put this fraction at the start. So 150 over 360 times by pi times by the radius squared. Well, the radius is from the centre to the edge of the circle, so it's going to be 6. So 150 over 360 times pi times 6 squared. And if I just put that into my calculator, okay, oh, it says no calculator. Oh, that's my bad. It's non-calculator, so let's do it. So let's simplify 150 over 360. Well, first of all, we could cancel out the zeros. So that makes it 15 out of 36. And then what times table are 15 and 36 in? Well, they're both in the threes. So if I divide them both by 3, I'll get 5 twelfths. Okay, so 5 twelfths times by pi times by 36, 6 squared. So I've got that now, okay? So 5 twelfths times by 36 pi. And then when we've got a whole number and we're timesing by a fraction, we just times the top together. So 5 times 36 is 180. And then how many 12s are in 180? Okay. What have we got? We've got 12 12s, which is 144. 13 is 156. 14 is 168. And 15, okay, is 180. 15 times 12 is 180. So it's 15 pi. Give your answer in terms of pi. Okay, so just a quick recap. It's pi r squared, just as normal to find the area of a full circle. But we've not got a full circle, we've only got 150 out of the 360 in this case, so that goes at the start. So instead of it being 36 pi, it's going to be 5 twelfths of that. And when you've got a fraction and you're timesing it by a whole number, you just multiply the top, the numerator, by that number. Okay, that gave us 180. Divide by 12 is 15 pi. That's like grade 5, but also it's a bit harder, that one, because it's on a non-calculator paper, so it'll probably be a bit more. And then this one, the area of a triangle. Okay, the area of a triangle. Well, obviously, at the earliest part of the paper, it's going to be base times height divided by 2. But you can see here we don't have the height. We don't have it. Okay, and we don't know how far across it is to be able to guess. Well, it looks like it's near the middle. It looks like it's a bit before. It's about 3 across. Okay, we can't guess these sort of things. So we can't use that formula when we get a little bit later in the paper. So we need a different formula. Okay, and the formula is a half AB sine C. Okay, so what does that mean? Well, little letters, they are your sides, and the big letters are your angles. So if you look at the diagram, we've only got one angle there, so that's going to be our big C. And the other two are just your A and your B. They just wrap around the angle. And all you do is simply put it into your calculator. A half times 6 times 7 times the sine of 60. Okay, and I've just said you put it in your calculator, but it's a non-calculator topic we're focusing on this week, which is absolutely fine. So 6 sevens are 42. Half of 42 is 21. All right. And sine 60, we could do the little hand trick. So for sine 60, this is 0, 50, 30, 45, 60, and 90. So we'll put our 60 finger down. We have got 3 fingers below the 60 finger. So it's going to be root 3 divided by 2. And I've taught a lot of you this in period 6 and in class. So sine 60 is root 3 over 2. So it's going to be 21 root 3 over 2. And we would leave it there, okay, because it is a non-calculator question. And there we go. So we've covered 4 topics today. We have looked at the surface area of a cuboid, we've looked at the area of a sector, we've looked at the area of a triangle, and we've looked at angles in a polygon. So on tomorrow's video, we're going to be looking at volume of a cube, a reminder on Pythagoras. We're going to look at some exact trig values, just like that sine 61 a second ago. And we're going to look at some vectors. Okay, so plenty coming up. Make sure you get to watch it. See you later, guys. Have a good night.